So I'm ready to go. Go live. Going live. Okay, can everyone hear me? Sorry about the delay there. Had some technical difficulties with the streaming side of it from the computer to YouTube. All right, so there's as you probably know already from so far, there's a chat on the right hand side there, and if you have a YouTube account, you can go on in there and ask any questions you like. You're also welcome to send an email to me if you need to send a file or anything like that. I'll just type my email in there now. Just josh@ironcad.com.au. And so basically with this webinar, the main thing I'm going to be doing is first going through a bunch of just tips and tricks, generalized tips and tricks, things that people often find very useful but don't know, and just really generally like small things, but they actually make a big difference to a lot of workflows. Um, so as well as that, at the end of going through these tips and tricks, we'll have a Q&A session. So if you want to start thinking about questions or just start asking them, and then we'll put together a list so we can go through them all in one go at the end. So I'm just going to jump straight into it here. And actually, I just rebooted my computer, so in trying to fix all of that, so I'm just going to start up IronCAD. Bear with me for a moment. Just boot IronCAD up. And so this first one that I'm going to be showing you is the selecting hidden features, which is used a lot with blend tools and things like that. So what I'll do is I'll just open up this blank example scene here for us. So this one's really simple. Again, it's this select hidden features here. We'll actually go through both of these in kind of one go here. So select hidden features and fast select IntelliShapes. So for selecting hidden features, what you're doing is selecting. It's actually faces and edges that you're selecting here, not hidden features. But it's for example here, if we're placing a blend around this block and we start putting some blends in, and we get to that edge. Now, obviously, in this case, it's pretty easy. We can just spin it around and click on that edge. But in some cases, if you have this block connecting into another model, or you have a larger and more complex assembly and things like that, it can be sometimes hard to actually get to that edge. So as long as you get your mouse in approximately the right position, you can press Control Alt on your keyboard, hold those two down, and then press the mouse key, and you'll get the other select option dialog here. So you can see it'll give you the three closest things that you might be wanting to select on. And one of those, of course, will be this edge at the back there. So we click that, and it'll just click through the geometry there and find that edge. Now, the next one here is the selecting straight down to IntelliShapes. And I'm going to open up this cardboard package, which I'll also show in a bit more detail later. But as you can see, this is an assembly. And of course, you can have assemblies like this as just a single assembly. You often have sub-assemblies under sub-assemblies. And to click down to a shape, obviously with every assembly you create, it creates another click. So if you've got 5 assemblies here, to click down to the IntelliShape is going to be one click for the assembly, in this case, another click for the pattern, another click for the part. And then if you add more assemblies, that click count goes up and up and up and up. Whereas most times, whenever you want to make any actual edits, you're wanting just to get down to the IntelliShape level, which is, of course, this level here. So what you can also do is you can just hold down the Alt key on your keyboard when you select. And if you're holding down that Alt key, it'll get straight down to the IntelliShape, which if you do have big, large assemblies and you have lots of selection levels, it really helps speed things up. It can also help when you're selecting multiple IntelliShapes. So if we go around here and we select down to this IntelliShape, and to start here, I'm going to say I'm not using the Alt key. And then I hold down the Shift key here. It's actually quite hard to select onto this next shape holding the Shift key because it's part of the other assembly. Whereas if I'm holding down the Alt key, and actually these are a pattern, so a better example would be one of these shapes. If I hold down the Alt key, I can select straight down to these IntelliShapes without actually having to select through their part or anything like that. Whereas if I was over here and I just wanted to select this, I just held down the Shift key onto another part. Generally, it would go to the part level first. So that's just like kind of something to note. Just holding down the Alt key gets you straight down to that IntelliShape. We do have a relatively simple assembly here. It's only got one level, so you don't get to see as much benefit as when you have a really complex assembly. But hopefully that all makes sense. I'll just bring up the next one here. Oh, thanks for that, Angelo. Let me know if that's a bit better. I just saw your message there saying the voice is going in and out, so to speak into the microphone more. So let me know if that's better or worse, and if anyone else has having problems there, just let me know. Yeah, I've just moved that a little bit closer, so hopefully we'll be a bit better there. So yeah, for shift key snap points, which is the next one, and lots of people know these from kind of in a simple context, in that you can hold down the shift key when you're sizing things, so that if we have two of these boxes next to each other, like this, we can of course now go in and size one to connect to the other. So we can hold down the shift key and then we get that snap point there. So it's snapped exactly into that location. But one part where this is often overlooked is holding down the shift key to snap to actual locations instead of when you're sorry, not locations, sorry, midpoints and center points instead of just locations. So if we go over here, and I'll just put in a cut into this block for the moment. And another thing you may sometimes want to size to are midpoints and endpoints and things like that. So if I just create another block on top here, we'll just drop that in as a part. If we're dragging this now to size it, and we want to go to the midpoint here of this edge, obviously it's pretty easy on a small edge to find the midpoint. You can find it like that. But if it's a bigger edge, sometimes it's harder to find. And the same here for this one here. So you can see with this circle, it's obviously relatively easy to go and find that point there, the center. But sometimes it's a lot harder to find those points on complex shapes. So you can see if I hold down the shift key, it's going to snap between those 3 points for me. So it'll snap between, if I just drag that back again, holding down the shift key will snap between the end point there. As soon as I get past a quarter of the way through this, it's going to snap to the midpoint. And as soon as I get past 3/4 of the way through this, it's going to snap to the end point. So it's just a very useful thing to know when you're resizing, because it can be really useful to get to those points like that and automatically get to them. So sometimes when you're sizing kind of a complex shape or positioning it, which I'll show you in a second with the tribal, it's much easier to find it like that. So you can see here, if we are wanting to move via this corner with the tribal, let's just move this out into space a little bit. If we were just dragging on this edge here, we can find the midpoint there. It's not too much of a problem. But this is a much bigger part. So in this case, we have a much bigger part here. The whole finding the midpoint there can be a little bit annoying if you have to kind of dig around for it. So once we're out here and we zoom out, we're kind of just trying to imagine where that midpoint is. And like, obviously you get the highlight there, the dark blue highlight. But on really big parts, you still kind of have to find and make sure you're snapping to that. So if you hold down the shift key here, you can see it's going to snap to the end or midpoints. So just by holding that down, even if I'm all the way over here, and you can kind of do stuff, even stuff you're not looking at. So you can do stuff you can't even see at the moment, and it'll be working. So you can see here, I can be dragging, hold down the shift key once I'm past halfway here, and it's going to snap to midpoint. I can just let go now of my mouse and zoom out, and now I've got that at the midpoint. So those shift key snap points are really useful when you get used to kind of activating them whilst you're modeling. Let's just move on to the next one here. Again, if there are any questions, make sure you ask them in the chat so I can try to cover them before I go on to go too far ahead. The next one is tribal dragging for alignment, and this one is often overlooked. Generally, with the tribal, there are a few main ways of doing things. So I'll just drag out another block here, another example block for us. So I'm going to purposely put this part into a really kind of complex and out of the way area. So we have this part, and this can happen depending on the type of assembly you've got. You can have lots of curves and things like that that end up having parts in the middle of nowhere, or even just end up having them on complex angles. Now, the thing most people know already is that to start aligning this into this position over here, we can right click here and we can say, okay, well, we want this one to be perpendicular to face, for example. And we just click on this face, and that's going to make it that perpendicular to face. And then obviously we want to align this axis too, so that's level. So we can do this edge, for example, and do parallel to edge, and we'll select onto this edge. So now it's going to be parallel, and in this case, we'll just reverse it with this button here quickly. But you can see now it's going to be parallel. And so basically we're aligning it with those right click and then select the related option here. This is more explanatory. You can actually read the options and go, cool, that's what I want to use. But with IronCAD, of course, it's all about productivity and doing things as the fastest way to go from an idea in your head to a manufactured product. So there's generally always even faster ways of setting things up and doing them. And that's the same with the tribal. So if we just go back here a step, so we are in that location there, what we can also do is just hold down this handle, click and drag on this handle, and I can just go snap to that face, snap to this face, and then we're done. So basically, when you drag that handle over a face, you're snapping to perpendicular with that face. And if you drag that handle to an edge, you're snapping to aligning to that edge. So it's doing the same thing as the right clicking and choosing an option. It's just doing it a lot faster and without you having to think about which one do I want to use. Once you get used to aligning these, you can just aim them where you want them to go and they'll move for you. And then, for example, flip that back up. And of course, the standard tribal snaps, which you are likely used to. And we can snap over to this edge. And let's start to make that even. Okay, let's go on to the next one here. The next one is adding IntelliShape handles to things. So and these two actually combine quite well. These use shapes, not sketches. In traditional and conventional CAD systems, the process is normally to create a plane and then create a sketch on that plane and then go through something like an extrude or spin or whatever you want to go through. IronCAD skips this step, and this can sometimes be forgotten how much time you can save here just by starting with a shape instead of an extrude. Even if you've got a custom cross section you're wanting to import or anything like that, there's still rarely ever a need to actually start with a sketch if you know you're going to be extruding into a 3D shape or converting into a 3D shape. So you can see here, if we go up and we just drag and drop out a block, and this is now a 50 mil or 50 mil wide by 27 high extrude, make it 50 mil high. And so the base that you dropped it onto is the extrude cross section. So in a traditional CAD system, what you've done here is you've placed a plane in this space, wherever you want it to be. If we wanted this plane to be over here, we'll put it over here. You've placed a plane on there. You've created a sketch on there that's the shape of a rectangle, and then you've done an extrude. So in IronCAD, it just skips those initial steps so that you can then just go in here and say, okay, we want to edit the cross section, and then you can make that cross section whatever you like. But it's still going to be the same result. You've still got an extrusion, but it's just speeding up the process a lot by skipping those steps. But that being said, sometimes you do want to do an extrusion using the standard 2D sketch and extrude command. So when you do that, one tip which I was mentioning in that tips and tricks area is that you can actually convert your shape into an extrude if you want to. Into an IntelliShape. So IronCAD IntelliShapes obviously make it a lot easier and faster to resize things. But if you just do a standard extrude here, let's just go through and we can just actually just right click on this and do create extrude, and we'll make it 50 mil, and we'll do a standalone part. That's good enough. So we've created an extrude there. But now if you go down to click onto the IntelliShape level, you can only adjust with these handles. You don't have the side handles or anything like that. You've got the cross-section handles, which can sometimes be useful, but they aren't as useful as the side handles. So what you can actually do is activate the side handles here. So you can right click, go into the IntelliShape properties, and you've actually got the size box handles sitting in here. So what you have to do is turn them on. So we turn on the length handle, the width handle, the height handle, and we can make these size about the start, and then we'll just hit from opposite handle. Actually, these can stay at anchor, I think. You can have no aspect locks, make sure we don't have any of those on, and then we're good to go. Now, if we click down onto that shape, we've now got handles like the other shape, even though this was a custom shape that we just made up. So furthering onto that, where you can go into more detail is this model over here. We've got those same push-pull handles at the IntelliShape, at the assembly level. You can actually create them at the part level or the assembly level or the sub-assembly level, so on and so forth. So you can see here, this one's a little bit more complex and it's got some parameters in it, but they don't even have to have parameters to be able to activate this. You can see here if I go into my assembly properties, so right-click, assembly properties. In my assembly properties here, we've got size box, dimensions, they're using these length, width, and height handles. So by default in IronCAD, the only shape that will use it is the IntelliShape with those handles there, but you can actually activate those on any part or assembly. And it is worth noting that it can be hard to set them up in a really nice way, like they are set up in something like this. It does take a little bit of work and maybe some help from us to get an understanding of the best way to kind of relate those handles to each other and things. But it is really important to note that you can go and do this and create some really cool stuff. So an example here, which is what this box is for, is that this actually has all these little IntelliShapes underneath it. So you can see this is, and to give you an idea of what this is, it's a cardboard packaging box. So just switch over to a different configuration. I'll show you what's kind of going on. And it just has some kind of mitered cardboard sections that are thicker cardboard to protect the box. And then it has some cardboard sheets sitting in here as well that also sit by themselves. And then if we just switch over back to the default configuration, we can go to the open one as well, which will give you a better idea of what's kind of going on there. And then if we just go back now to the full model, so I'll just go to the default configuration. You can see now when we stretch this, all of these parts underneath it are going to change in size. And if you watch the feet here, which these wood blocks, they're going up in number. Their pattern of those is actually changing in number as we stretch this out. And then, of course, if we make it longer, it's going to keep adding them. If we make it shorter, it'll take them away. And so if we dig down into this, how this model's made, you can go in and see that there are actually parameters sitting behind this that drive all those values. So these look a little bit more complex than they are, but you can see here we've got basically if the width is below 1001 millimeters, use 2 feet. If it's above that, use an integer of 2 plus width divided by 1000 millimeters, which in this case makes it 3. So there's a few different kind of values in there that help define all of the parts underneath it. So all of these shapes, like this IntelliShape, things like that, they've all got you can see why these handles are blue, because they're actually defined by those formulas. So it means you can drive all of your parts underneath your assembly just with one, 100's a bit small there. Wasn't built to be able to go that small. So as you can see, you can drive all those parts via the overall assembly. Okay, I'll continue on now with the next ones. A bit sidetracked with that shape, but it is a cool model. Direct editing imported parts. This one I'll cover really quickly because it's not often needed as much as everything else. But this is basically when you import a part and someone sends you a part like as a step file or parasolid file or anything like that, and you want to edit it. And IronCAD's actually extremely good at this compared to conventional systems going in and editing imported stuff like that. But you just need to know what tools to use. So I'm just going to go ahead and make a fake imported part. We'll look over to our example scene here, and let's just resize this one back, and we'll delete this one. And I'll just go in and customize this shape a little bit more. And stretch this down, and then let's maybe add a chamfer on here as well, and move this IntelliShape back. So let's say this is a part that we've imported from someone, or someone sent to us in 3D, and they're saying, "Hey, this is the part we need to change things," or even a part you found on GrabCAD or something like that. And you want to change it up to be able to suit whatever needs you have. So what I'm going to do is I'm just going to combine all these shapes together into one, which is we'll leave it as a BREP file or boundary representation file, which is what you get when you import a part. So you can see it's going to combine all of these into one. Instead of having all those features there, it's just one shape. What IronCAD does is it's quite good at recognizing what things are when you import it like that. So you can see they've got these handles in here. Like I can drag this, and it's going to reduce that chamfer height. But you can also right click and select edit value. And then, for example, say we want it to be an extra, an extra 2 mil. And so it's going to drop that downward 2 mil. Things like radiuses, like here, we can go in here and we can actually select onto that face radius and then right click, and it'll figure out that it is a radius, and it'll say edit face radius. Now we can see that it's currently 10 and we want to make it 8. So we'll just type 8, hit OK, and it's going to edit that geometry to make it 8. We could have selected both of them, and in this case I'll just go and select this one as well. So it's just a really simple example of that sort of work, but it can get a lot more complex than that as well. I mean, one thing we'll do here as well is also use the tribal. So I'm going to activate the tribal on this shape, and I'm actually going to move this face so that it's on a different angle. So right now it's going to be a 45-degree angle. Of course, we have no chamfer feature or anything there, so generally it's very hard to change that over a different angle other than creating a new shape. So what we can do is just use the tribal and say, well, we want this to be a 35 angle, so we're just going to raise it 10 degrees, or maybe we'll make it a 30-degree angle, raise it 15. Just hit OK, enter once and enter again, and you can see by activating the tribal on a face, it takes you straight into the move face command automatically. We click OK, and it's just figured out the rest for us. It's just said, okay, well, that's where they want it to go. We'll just figure out the rest of the geometry to make it work. One last thing for editing imported geometry like this is that you can select down and create IntelliShapes. So if we select down to a shape like this, where we're selecting all the faces that encompass that shape, we can then right click and do faces to IntelliShape. This is going to convert them over to a different face and then create a pattern from them, from whatever it thinks is the best option for that pattern. You can see it's actually created a pattern via the midpoint of this shape and created those two in that pattern. So these will always stay the same and stay matched. So it means that if we change one of these and change its cross section and say, well, actually, we need this one to have a little keyhole cut out on one side, then it's going to automatically change that one as well. In this case, though, actually, because this one's rotated, we want to actually disable that pattern, and we'd want to change not have a keyhole instead of, because you can see that's on a little bit of an angle, which is not what we want. So it's not always perfect for what it recognizes as you wanted it to be in that case. Obviously, if this was a round shape and it was a circle, then that would have been great because it would have copied that round and followed the tangency of the pattern. But you can see here, as a more realistic example, obviously, as well, you can go in and change the shape to be bigger or smaller, which is a much more realistic change. And even with this one, that would still be working fine. But you can also, if we really needed to, I'd just delete that pattern. If this was something we needed to do, put that keyhole in there, for example, and we just do a link of this first shape. And then we've got the same result. And we can just go in here and create that keyhole. Because it's still just recognizing, it only needs to recognize one shape for us to then be able to use IronCAD's normal tools to use that shape to then power the next change. So I think that's probably about it for those sorts of direct editing tools. There's actually a lot more that it can do than that, but this is just a simple example. But I hope that's helped. let's now jump back in here and look at materials in catalogs. Um, this one's good for good to know for when you are using both weights on materials or just colors. So one thing that's often not done is actually put your own materials in catalogs. As you would know in the new starter catalog here, we have got a relatively um, simple selection of materials. So we've got like a stainless steel and aluminium and so on and so forth. And if we drag those out, like this titanium, it's going to add in the titanium mass density into the part. So it's actually the weight of that titanium. So this would currently weigh 0.19 kilos. But these materials here are all completely customizable. So you can see these ones that don't have a little M next to them. These down here are just colors. And as you may know, we already have our huge material catalog, which is mainly for just the actual um, actual weights and things, which has all these different materials in it. But sometimes you want to create your own material and you want to have your own color, etc., and your own mass density. So in this case, I'm going to go into this material here, and I'm going to right click on the part, go to part properties, have a look at the material. I'm going to just call this one ABC, and we're going to change the mass density to 6,000. I'll hit OK. And so with that, and now we'll go in and also go to the Smart Paint tool. So right click and go to Smart Paint. Maybe we'll make this material semi-transparent. And you can add all sorts of other things here. You can make it emit light if you want it to. Maybe we can make it a little bit more reflective. But just a really simple example. And now this is going to have our properties on it. Now, if I go to the Smart Paint tool, which is up here, I can go to the Fill Eyedropper. If I click on that, it's going to fill it. You can see the little tool filled up there. And if you click into the catalog, it's going to place that paint. So it paints other products the same color. But if you right click, it'll paint, you can paste the Smart Paint and the material. So that way, you can see it's got a little M next to it now. That way, it'll actually copy the material properties as well as the color properties. So we have just a random block sitting over here, or maybe two random blocks. If we drag the paint, actually, I'll just show you what this block's properties are first. The mass density is currently 7,800. It's just got the nothing default material. So if we drag this one out, it's going to make it green like this one, but it's not going to change that mass density or change the material type, just the color. And that's obviously still useful if you're just wanting to copy colors between parts really quickly. Like obviously you can, in the one model, you might have multiple parts with different materials that are the same color. So sometimes you want to just copy the color, not the material. This type of one here will also copy the material properties. So if we select down onto this one, it's now got our ABC material at a 6,000 mass density. Let's jump back into the catalog here, not catalog, tips and tricks here. This one here is repositioning snap points. There is another page here, so hopefully I'm not going too slow for everyone. So repositioning snap points is just for sheet metal, and it is a really valuable one to know. So if we just go ahead and maybe I'll leave that green part in my catalog just in case we want to use it later. But I'll just delete all of those. And we'll go in and bring out a sheet metal part. Now let's just change this stock over to something a bit thicker. Let's go to the 2mm aluminium here. And then we'll size this to say 200 by 150. And let's bring out a bend here. And then size this one like that. Now we're going to have another bend that's going to go on the top here. There's another bend that sits up here. I'm going to align this one vertically. So I'm actually just going to right click here and do parallel to edge. Go down and select on this edge. That's going to make it parallel, pointing directly up. So one thing here that you can often run into is that you want to size the sheet metal shape, but because it's got this in the middle, it's really hard to figure out how long that should be. So I'll show you what I mean with a little bit of kind of reference geometry for where this type of problem might occur. Let's drop out a new part and stretch this part out over to here. And then I'll copy that part up into, I'll copy the IntelliShape actually, 90 degrees. And we'll then just resize this across. So this is kind of our fake wall. So what you might sometimes find is that you've got this positioned into a type position like this, where you want to actually size this sheet metal model. This side can't move, the left side can't move in your model that you're working on, and you want to size this so it hits that wall. And this seat needs to stay the same size, but this is the only thing that can change. And so if you're just trying to get it there, like on the side like this, most of the time you can get it really close, but it's not exactly on there. I'll just turn off perspective so you can see what's going on. So you can kind of do it like this. And I mean, for most manufacturing tolerances, because you can get down to something like 0.1 mil or something like that here, or a lot smaller than that. Basically, get down to as low as you want to zoom in, but it's still not exact. And so it can kind of be a little bit hard to get this to go exactly where you want it to go. So what you can do with sheet metal parts is you can actually change the snap point you're using for that piece of sheet metal. So if you right click on the endpoint of a bend, you can set the handle snap point, and you can also set its orientation. So I'm going to set the handle snap point first to be onto this face. That's the face we want to align with the wall. Then I'll right click and do set handle orientation. And we're going to also click perpendicular to face and then click on that face. So you can see that handle down there has now moved so that it's facing this way. And when we drag it, it's actually going to use that top point there as its reference point. You see when I hover over it, it's showing what the reference point is. So now if we hold down the shift key and we drag this and snap to that wall, it's going to snap exactly into place. And now it's going to be a perfect fit going up against the wall there. Let me use the look at tool so we can get right on that. So you can see that way you're sizing via the length of this, which is kind of generally a hard size too. If you wanted to calculate it yourself, you have to calculate it using the angle. And this way you can just, doesn't matter what that angle is, size to that flat surface there with something like sheet metal like this. Cool. Let's go on into the next page there. Transferring BOM data to 3D. So let's just go in and open up another file here. Let's open up this steel frame. So this steel frame is a little bit like the parametric package there. It's just a steel frame instead. And it's still a pretty simple version, but basically it'll add more frame beams here whenever you go in and stretch it. But let's go back and make it small again. We'll make it 1100. Let's go in and create a drawing of it. Now, one thing as well that is often very overlooked is the bulk drawing tool. So I'll just quickly show this before we do the BOM export thing we're talking about. So it's really worth getting used to using this because it's extremely powerful. You can just click bulk drawing, and I won't go through it in detail here, because it's it's obviously I can go through it in a lot more detail than this, and it's not the main thing we're focused on. But basically, I'll go in here, select my bulk drawing, and do this one with a BOM. It's just an A4 sheet. It's a pretty simple one. We're going to do this corner. For this corner, we're going to use the custom bulk here with 4 views on it. You can see it's going to gray out the ones that are the exact same because it knows they're the same parts. So it says there's no need to select those. And we'll go in and select anything else. And again, use that template. I should just set it as my default template. That would make things a lot easier. And so on and so forth. We can go down here and select all of these parts. So now what we do, now we've got those selected, and defining the front views is important for this, which I don't think I've done in that model yet. But you can see here now it'll go through and it's just going to automatically generate all of your views. So I'm not doing anything now at all. I'm just sitting here and it's going through and creating all those pages for us. So it's created all these different sheets with all the different parts on it. So now all we need to do is just go in and place our dimensions in there, and then we're done. So obviously it speeds up view creation a lot, and it also means that what you can do is you can set up your own bulk drawing templates. They're going to do this. You're going to use your own kind of exact data you want. You can see if I go over to the steel frame one here, which is the assembly one I used, this one's also bringing in for us the actual isometric view of the whole model and doing a shaded rendering on it. You can also set it up to use sheet metal unfolded view, so automatically place an unfolded view of your sheet metal part alongside the normal view. So it's quite good, and it definitely saves a lot of time. The main thing is just understanding how to create the templates, which if anyone wants to know how to in more detail, they can send me an email or have a look. There's a few videos online on that as well. So let's just go in and I'll just delete this bomb and place. Oh, actually, I don't know if my bomb template's here, so let's just redo. Or we'll find out if it's there. It is here actually. So this cut list template. It's just my simple template for steel. So you can see here, it's just got the part name and the material and length and then cut angle of each section. So we've got 45, 45 on those ones, and the quantities obviously here as well. So in this case, we'd probably want to drop the scale down a little bit so that we could have our bombs still fit on the page. But one thing that's really important here is that, for example, let's say you wanted to change the some notes on these parts. I'm going to add in a new column to my bill of materials here, and maybe this is the supplier column. Doesn't really matter. Main thing I'm wanting to show is just changing columns from 2D instead of 3D. So if we go in here and just add a new column, drag it over to the right here, and let's go in and add something in here. Just thinking of what's a simple one to add that'll be useful for us here. Let's just use the supplier one, I guess, and hit OK. Right now they haven't got any supplier properties, so that's just going to be empty. But as you may know already, if we went in here and just tried to edit this, and we want to say this is ABC supplier, what's going to happen is that when we update our model, that's going to disappear. As you can see, update the bomb. And the reason that is because the way IronCAD's set up is to run everything out of 3D. Because 3D is the most important part. If your 3D is 100% accurate, your drawing is going to be 100% accurate. So everything bases itself off 3D and uses that data. 3D model should always be the most updated and most accurate version of what you're making. So that way, all the 2D models can just be driven by that. So that's why it does this, in that it always checks what 3D is, and the supplier column in 3D currently doesn't say anything. So when we type it in here, it's saying, hey, no, that's different to 3D. We've got to change that. So we can obviously go in here and edit the supplier column on every part. Go into the part properties and go into the custom fields and enter a supplier column there. But that's obviously, so we just go in and click supplier, type in supplier, etc. Each one. Obviously, when you have a complex file, this one's still pretty simple. If you have a complex assembly, say of 100 parts or 1,000 parts or 10,000 parts, that's a big job to do, to go and select onto every single part just so you can add a change like that in, which is just a text-based change. So what's quite cool, which you can do out of the drawing here, is you can go in and type what you want to. ABC, we'll go to the next one. This next one can be XYZ. This next one can be ABC again. This next one can just be lots of underscores. This next one can be whatever numbers I press on the keyboard. And now we have our suppliers. And so now, again, if we tried to update this, it wouldn't work. It'd clear it. What you can do is you can right-click and you can select Assign Column Property Values. What this does is it performs a one-time transfer of those values over to the 3D scene. So this is basically you telling IronCAD that I'm confident with all these values I've put in here, and I want it to overwrite those values in the 3D scene. And so it'll transfer them to 3D scene from whatever column you choose. So you can see I want these to be transferred from the supplier column to also the supplier column. So we click OK, and it says successfully set the column properties. Click OK again, and we can update the BOM, and now it's going to be working perfectly. And now if we go into any of these parts, we can go and see they have a property in them. So now you can see in the custom properties, you've got supplier, the values X, Y, Z, so on and so forth. Now those values can be anything you like, whether it's a revision or supplier, or if it's been checked by someone, all sorts of stuff. But it can be really useful to be able to update those from your 2D drawing. Okay, let's jump back into the page here. Selection filter is also something that's often overlooked when you're working with big assemblies and things like that. So again, it's not too big of an assembly, but it's still a good example for this. So if you're trying to select down, you're trying to select multiple parts and things, you select down, that's a pattern. Now we're on a pattern. We don't want to select a pattern. We just want to select a part. So we've got that part. Hold down the shift key. Now we've got the pattern there. We don't want the pattern. So I'm clicking again, but it won't click. The trick here is to actually hold down the shift key, click once, click again, and it'll take you down to the part. Hold down shift key. Stuff that isn't patterned is a little bit easier. But if it's assembly, then it's even harder. You've got to click and then click again. So it kind of makes it a little bit hard to select down if you have lots of levels in there, like patterns and assemblies and things. So what's really useful to know about is the selection filter down the bottom here. So let's say, look, we're just wanting to take a few parts out of here and copy them into somewhere else. Just save them to the catalog. So instead of having to kind of select down there to the part level, then try and select the other part, or that one's linked, or try and select this part, get to this one, hit the pattern, so on, we can just change the selection filter over to part. And then when it's on part, first click's going to be on the part. So just go straight to the part, no matter what. And it makes it much easier to then just select the parts we want. And in this case, we're going to select both of those and we'll drag them into the catalog. So it's much easier. Then we'll select one. So obviously this one's the dual part, and then the other one's the single part. And works the same with assemblies at those levels and that sort of thing as well. If you're on the assembly filter, of course, it is important to go back and make sure you change back to the any filter before you start working again, because otherwise it can get a bit confusing. The same thing works for IntelliShapes. If you're just wanting to select IntelliShapes, drill straight down through to those. Again, you can also do that with the Alt key. Sometimes it can be useful here too. Same works for edges and faces and things. So like if for example, face is a good example, because sometimes you want to select on lots of faces, but you don't want to select the edges. And if you're trying to select around with it on any, it can be really easy to select the edges as well. So if we just go here and select down to that level, which is the face level, holding down the shift key here, look, I've accidentally selected an edge, and then I'm getting close there, I've got selected another edge. Now I've actually got that edge selected. Whenever you hover over an edge, it's going to select an edge as well. By using the face select or edge select and so on, you can then just go around and kind of do it faster, because you don't have to be as careful when you're selecting. It's only going to get faces. So it makes it a little bit easier to go and do that. And in this case, there's obviously lots of different uses you could have for faces, and we could go in and we could make a flat pattern from them, but that's going to do the same thing there and make a flat pattern from the faces, but I won't go through and do that for now. And let's go in and jump back to the page here. Control drop to replace parts. So that's really good to know when you've got to replace parts in a complex model. Let's open the tank catalog if we've got that in here. We do. Let's just open up a new scene and we'll start dragging and dropping out our tank. This is a cool example catalog. It's included in IronCAD default install. So this is just, you have this catalog in yours as well. And we'll start with the tank shell. This is in inches, but you can always change the parameters over to millimeters. It's mainly set up as an example. So you can see we drag and drop this out. This is a sheet metal part. So it'll unfold, give you a flat pattern. And now we're going to drag and drop this tank ring, and it's going to match the size of this part. Whatever that size is, it's going to match it. If we go up here, drag the tank lid out, it's also going to match that. and it's going to match up these holes as well. Obviously, there are only 4 holes in the base one, and there are lots in the top one, but it's still aligned those because, for example, maybe the top plate only comes with 10 holes or 15 holes drilled in it, but the bottom plate you have to drill them yourself, so you only want to put them in those specific places. Basically, what it's doing, it's automatically matching the sizes for those parts. What I'll quickly do here, though, is that I'll change the default rendering on these parts just to a little bit smoother so we can see the alignment a little better. Generally, I default to 60. That's with a relatively powerful computer. The the higher you go, the more computing power it's going to use on complex parts. So it's not worth going too high, but it is worth to smooth things out like that to get a better look at them as well. Now let's drag out the tank bottom here, or maybe we'll use the cone bottom. See, that's also sheet metal, going to snap there and give you an unfold pattern. Drag out the leg assembly. In this case, we've only got 3 legs there. So what happens if we want to make 5? We can right click, and this has got no design variations at the moment. But if we wanted to, we could add them. Now we could go into the leg parameters here and see the current leg quantity here is currently set as 3. So I'm just going to go in here and say, hey, I want to make that 5. You apply it, it's going to make 5 legs there. Now, let's just drag out this base pad, which is the main example I'm wanting to show here. So let's just say we want to swap out one of these base pads. And so this is obviously an entire assembly here, not just a part. But we're gonna swap out the individual part. So and this is linked around, so it'll be swapping out swaps out all the parts. But actually no, we may just swap out the one part. But what we're going to do is swap this out with a control drag instead of trying to reposition a new one. So let's say this is a job that, for example, the plates need to be changed, or a new job where a new type of plate is going to be used, or it's an existing job and it comes back and the plates need to be changed. What we'll do is we'll just drop one of these into our catalog, so this base pad here, and I'll just drag and drop it out again just so it's by itself, empty part. I'm going to go in and customize it a bit. So what I might do, I'll just do some really simple changes, but maybe I'll cut out. We want to take some weight off this. It's just really simple example, of course, but maybe we want to take some weight off this. So we're going to cut a hole in the center, and then we're going to put some holes along the outside. Copy that here, and we're going to stretch that out to be 100 mil, and then push it out to be let's say 40 mil out there. Maybe I'll make this one 200. And it's just going to be like that. And now what we want to do is we want to copy this around. So we'll just activate the tribal and spin this around. Here, 3 at 90. So we get that copied out. And now let's go in and just change the color of this, just so we can make sure we see our difference. And let's just make it a blue. So now we have this brand new plate. And the most important thing is that this anchor remains in the same position. Now you can see if we jump back into here, into our catalog, or we'll just find the one with the base pad, we'll drop this one in here as well. Now when you drag and drop this out, obviously we could go in and delete that and try and position this one with the exact same position and location and things. But that's going to take a few steps. What you can also do is just hold down the control key on your keyboard when you drop that out. Actually, we're replacing the assembly there, which we don't want to do. We want to click down to the part level. We can drop that out and replace that part. And in this case, actually, this is a bad example for this demonstration because it's because we've got a pattern going around there. So let me undo that for a second and disassemble our assembly there. To give a better kind of example, see, this one's still in a pattern. This is not a very good example for this part I'm doing. What we'll do is we'll just delete. It's because I think it's also because the whole assembly is built to match up to the attachment points on the assembly and not on the part. So let me just go in and delete that, and we'll delete this one here as well. Let me just find where that one is. It's under this pattern. So you can see here, this one's a single one of these, which is a better example for us. We can obviously add it into a pattern going around. If you hold down the control key on the um, part there, it's going to automatically drop out. I was just holding down the function key, not the control key. So you can see we can swap out these two parts instantly, and they'll be placed into the exact same location. So this can just be two parts like I've got here, or it can be tons and tons of different parts that we can just drag and drop out and just drop them back in. And it's going to be able to replace those really quickly. And of course, in some examples, you might have 100 different type of base pads you can use, and you can just drag and drop them out and just automatically place them like that. So yeah, it's quite a useful thing. We don't need an old one there we created. Quite a useful tool to know of. Let's jump out of our thing, go back to our example here, and jump back to our images. Front view definition, that's an important one, which I mentioned quickly before in the 2D, the bulk drawing. If we go and have a look at our drawing here, we can see that because I didn't set up the front view definition, we can see what we have here is that we have a few of these parts which are just on a little bit of an angle. So like, not a little bit of an angle, basically a 90-degree angle. So you can see here, this one, we obviously want this to be on its side. So what you want to do for that type of shape is actually define its front view before you go into the bulk drawing. This can be useful if you have parts on complex angles as well, because sometimes when you go in, it's not a standard angle. So rotating by 90 or 45 degrees doesn't solve the problem you're wanting to solve. So what you can do is you can go in and define the front view now in the IronCAD settings. So if we go into one of these parts, we can click down, right click on the part and select front view definition. Now we can actually define that front view. So we click the face, so front view direction and horizontal direction. And we can click on the arrows to flip them if we need to. So you can see now the front view is going to be like that on its side. And now if we go and create that view, it's going to automatically default to that front view. This can also be useful with, for example, unfolded sheet metal parts that are on a strange angle. So then you can define the front view. You don't need to use the look at tool to get directly above them or anything like that to create your view. It's automatically going to use that front view you've predefined. So that's another useful one. Tribal on drop is just something really simple, which you can do if you have a part that you're going to move every time you drop it. So something like, for example, this is probably a too simple example, but if we drag out a block here, we'll go back to our example model here. We drag out a block to cut a hole in something. Very often when you drag out a block like this, you're going to want the tribal straight away. So what you can actually do now in the catalog is right click and just select attach tribal on drop. And basically all that does is, as it sounds, is when you drop it, it's going to activate the tribal straight away on the anchor of the part. So you can also move the anchor of the part if you're wanting to change how the tribal is aligned, if you want the tribal to align with the far edge and so on and so forth. Basically, it just skips a step for you. So you could even have a hole that uses the tribal and a hole that doesn't. But obviously, skipping one step there that seems relatively simple. And if you're dragging out things moving the tribal 3,000 times a day, one step there that saves 3 seconds or 2 seconds or something, it'd still be very useful. So yeah, worth keeping that one in mind as well. Shift increments on the tribal and IntelliShapes. These are often forgotten for sizing things. And then you can actually have increments for your IntelliShapes. So let's just make it a standardized number, even number like that. And then we'll just go in and change the snap increments. They're currently at 0.5 mil. I'm going to make them 10 mil. I just did that by right clicking on the handle. Now you can see if I hold down the control button, they're actually going to snap to precise sizes. So instead of snapping to snapping to just a random dimension, if I'm just not holding the control button like that, they're going to actually snap to increments of 10 mil. So they're always, when I'm holding the control button, they're always snapping to those increments there. It always ends up being an exact amount. That's just worth noting. So you can see as I'm sizing here, it's only going up in 10 mil increments. It won't let you go, 49.99 or anything like that. So you can just see how that adjusts there. So that can be a useful tool. The same thing goes with the tribal. So if we drag out a shape onto here and we want to rotate it, we'll drag out a new part, we'll stretch it up, and now we want to rotate this. Obviously, for just 90-degree rotations, you can use the really quick tribal things like that. But if you're wanting to rotate 45 degrees, you would generally go in here and you would drag, and then you'd say, okay, I want to rotate down down here. So, or let's say we want to rotate down to like past 180 degrees to let's say we want to rotate to 90 underneath, which is going to flip all around to the other side, or 270 would be around here. Or on this side, if you wanted 45, obviously, and full angles, but it can be kind of difficult to get, not difficult, but it can be time consuming to get the angle you want if you have to type it on the keyboard. So what you can also do is hold down the control key on the tribal, and it's just going to use 15 degree increments. So you can just drag this, and it's always going to snap to 15-degree increments, no matter where you put it. So that can just be really useful if you are. I'm just holding down the control key here. That can just be really useful if you're wanting to just move something quickly to something like 45 degrees, or just a specific amount that you use often that isn't 90 degrees that you can auto snap to and things like that. So that's just increments there for shift snapping and the tribal. So let's jump back in here to next one, which is S key shortcut bar. This is something that lots of you are probably familiar with, but just now it's been disabled by default so that you activate with S key. This bar here, and there was definitely mixed feedback on liking it, not liking it. I didn't really like it, but basically I didn't really like it when it came up by default. But it is actually quite useful if you know how to customize it. So if we know how to customize this, we can, for example, just select down to an edge like this, activate it, do a blend. And it's just going to drill through, do a blend for us. So it can be quite useful, but you just need to know how to customize it. So when you activate it, this top button here, that'll customize the option. You can select the command state it's in. So if you're just in the scene, it'll give you all these options. And you can add new 2D drawing there if you want. So if you know you're going straight into 2D drawing, often really quick, just add new 2D drawing, click S key, click new 2D drawing, so on and so forth. You can customize those, and you can choose where it shows up if you want it to show up at the top of the window, like that, and that sort of thing as well. Yeah, it's just worth noting that can be made useful when you customize it to suit your needs. Changing part smoothness, I actually just showed that before, but that's just a really quick one on when you have a circle and it looks like it's kind of jagged. My part smoothness is way too high for this to show up. So let me just bring in a new part and drop its smoothness down. So the default part smoothness on most, like on the default install of IronCAD, is going to be 30. So while it looks okay if it's small, if you bring this out and start to get a bit bigger here, you can see the edges look pretty jagged, and that can be a bit annoying if you need to line things up, or just annoying to look at. And basically it does that to speed up performance on slow computers. But at the end of the day, when you get the model, the maths behind it is still a perfect circle. But it's just doing it to speed up the graphics performance. And of course, when you go to produce a cutting file or a 3D export or anything like that, it's always going to be perfectly accurate. But it's just doing this to improve the graphics. So what you can do, especially if you have a computer that is powerful enough to do it, and you can just test if it is or not, is you can change this through that area I went to there, which is just the part properties rendering on an individual part basis. Or you can go in here and you can change it by default. So you go into the options and then go to parts and just change the default. And see my default 60. It's just double the normal size. So obviously that's going to use double the graphics power, but if your graphics card's powerful enough, then there's no problem. And I'm using a laptop with only a 4GB graphics card here at the moment, so 60 is no problem on this. Cool. That's the only other one there was snap to point for large shapes, which can be useful. And I'll just really quickly show you how that works. If we go in here and we have something really big to snap to, we have a really big shape. So if we have some huge shape like this, and we want to cut a channel in it, and we want to cut the channel up here. Now, the obvious next step, once we've cut the top of the channel, let me just select both sides symmetrically. Once we've cut the top of the channel, the obvious next step is to go in and stretch it to the end. But it's kind of difficult. You have to zoom whilst you're scrolling, scroll whilst you're holding down, get there, hit the shift key. It's okay, but it's kind of be annoying sometimes. And especially sometimes you have to navigate around if you have a big assembly with complex parts, you have to navigate around what you're actually seeing to find the point you want to snap to. So what you can also do, which is just sometimes just forgotten, is you can actually right click and just select 2 point. And then you can just mouse around like you normally would, doing kind of, navigating wherever you like. And then when you get to where at the right location where you can see where you want it to go, then you just click and it'll go there. So that's just worth noting because it can definitely make things easier, knowing that that's available to do when you have those sort of complex sizing operations. Um, Cool. That's it for those tips and tricks. If you guys want to submit any questions you have, I will go on to this next page here really quick, which is just these new hotkeys that have been preset now by default. So all of these are active, even on your machine, and you can also adjust them as well if you want to. So you can set up your own hotkeys to do whatever you want them to do. But it's worth noting that these are all now preset. So F is going to take you to front view. So if we're just in a standard file here, let's go back into our cardboard package, for example. We want to see the front view. Just hit F on your keyboard. It's going to go to the front view. T on your keyboard is going to go to the top view. I is going to go to isometric view. If you want to look at something, you can press W and then click on the face you want to look at. It's going to go directly to it. Activating the tribal Q key, obviously, that's probably a known one. That's probably the most valuable keyboard shortcut I can think of. And there were a few others there, which I've now forgotten. Fit scene, one good one for fit scene, which often gets forgotten, which is really important and really useful, is double clicking the middle mouse button. When this is over here somewhere and you want to get it back, double click middle mouse button and it's going to fly back into the middle of the scene for you. Same as clicking the D key for fit scene like that, but keep in mind middle mouse button, double click, going to bring it straight back because you're obviously already using the mouse, so it's a lot easier to double click middle mouse button than it is to click the fit scene button down here, or it is to press the D key. You can just double click middle mouse button and it's back. Worth noting that because that is very useful. Cool. Does anyone have any questions at all? Just type into the chat, and I can go into those. But otherwise, I think that's about it. Is there anything anyone wants to see or anything like that? Just let me know. Obviously, you can always reach out if you want to see something specific, and I can make you a video over email, as many of you are probably used to. But yeah, let me know if you've got any questions there in the chat. Cool. I can't see any chat messages coming in. Only other quick example I thought I might show is just a quick rendering example using Keyshot. Have a lot of people recently just enjoying Keyshot, and I thought that's a good example to show because it is something that's really easy, a lot easier than you expect it to be. If that's that's kind of I guess the best description for it in my mind. It's a much easier. When you see the quality of renderings you can produce, it's crazy how easy it is to do them. But let's just bring out something else that's a little bit kind of more exciting for us to render. So let's open up a new scene. We'll use our example scene actually. Go back into here. This is our empty example scene. And I'm going to go in here and we could use the robot catalog. Yeah, let's use the robot catalog. May as well. It's probably just not going to be that exciting. It's not many materials. It's pretty much all metal, but it's still somewhat exciting. Let's drag out the robot and snap that together. And we've got the elbow, arm, and wrist and the endpoint. Oops, missed the snap point there with the endpoint. As you can see, don't want it over there. Just want to make sure we get onto this so that it snaps into place. So with this model, it's got some nice smart attachment points sitting on it so that it will automatically move those, automatically give you some movement constraints there. So if we jump into mechanism mode and just use standard kind of relaxation behavior, you can see we can just drag this around and it's going to use all its constraints to match up to whatever we're wanting to do. So let's leave it there for now though, and let's jump into our keyshot side of things. So the most important thing to note with keyshot is it's going to match up everything that's the same color. Everything that's the same color in the model, it's going to treat as the same material or same type of material. So what I'm going to do is just go into add-ins and I'm just going to click on keyshot options. I'm going to turn off use single shelf apart, which means faces are separate to um, so like basically it means that, so you can see this engraving, for example, like that, if engraving, embossing, this is painted on to get that black shape on the top there. So like it's not a different material, if that makes sense. So if you want to do stuff like that, you want to make sure you don't use a single shell, because a single shell means it's all one material if it's the same color. I also increase the surface smoothness here using one of the IronCAD mechanical tools, which will just set the surface smoothness for all our parts in one quick go. We'll set it to 80, hit OK. That's going to automatically update that for us there, which is quite nice. Cool, let's jump into keyshot. So click render in keyshot. And then we'll jump over into keyshot with our robot. And we'll hit escape there. And it looks like our scene. This is a brand new install in keyshot. So oops, got that onto my other screen now. So it's stretching huge. Let me just shrink that down and make sure it's on just this screen. So you can see that robot there in our environment. Let's go in and just make it a white background. Looks like our environment settings have our environment quite huge here. Quite small here, sorry. Where's the environment size? That's what I was looking for. Let's change this one back down to where it was here. Environment's too bigger now. So now we're getting the shadows. That's basically what I was aiming to get there. And let's zoom in a little bit so we can see what's going on. Now we can go and add in some nice materials. Let's make it a green robot this time with, let's use some anodized rough green. Go onto that. And we use a polished black just on the bottom. And let's go in and add, as I mentioned, we're not using too many complex parts here, so it's not too exciting. But let's go in and add something else like a hard, shiny plastic green to go onto that front section there. So it's just a really quick example, obviously, of doing that. But you can see how quickly you can get a really nice looking render of a model. And so you get really nice lighting reflections and things. And that's literally, as you could see, 5 minutes or so of setup. And you can just moving animations of this and things like that if you want to. You can also go into far more detail to the materials and do brush metals, or you can do wood, cloth materials and lights and that sort of stuff. All I'll do here though is I'll just change over our environment, for example, to be maybe a factory floor type environment. So that's an industrial kitchen. That's probably not what we want. We've got this outdoor industrial kind of facility. Let's just go ahead and use that. Unless there's one that's more suitable for what we want. Just outdoor indoor. There's another one I don't know. Just don't know where it is off the top of my head. There's another one that's also a nice one. But let's just drag this one out, for example. That's going to use the lighting from that environment. So you can actually take a 360 photo with a 360 camera and create this if you want to as well. Create your own environment. So you can actually take a picture of the real environment the machine's going to go into and then reposition the sun and so on and so forth. So you can get it in the exact position it would be in real life. As you can see, this one's pretty, has some pretty crazy lighting, this environment. Let me just drop that contrast down a lot lower. You can see you get real world reflections and things like that. So it looks really nice. And if you are using a real environment, it looks even nicer there. I'm just going to keep upping the brightness here a little bit so we can get it looking the way we want. I'll just increase the ground size so our shadow flows all the way there. So you can see there, if I zoom in real close to, for example, up the top here, you can see the reflections in the background of our model. I'll just let that res up there. And with Keyshot, it's used CPU's rendering, so it's going to use your CPU to make it as high res as it can, and it's basically higher and higher and higher resolution as you let time go by. So, and you can obviously do your renders as well. So you can see up here, currently using 75% of my CPU. I can set that to use all my cores if I wanted to, or just some of them, so it does in the background. As you can see, they can do some really nice photos. And close-ups and do cutouts of models and things like that, so you can show inside them. It's really good for marketing imagery and photorealistic renders. So yeah, I hope that's helped. Another thing to note, of course, with Keyshot, it's really cool. They've put a lot of work in VR and XR, mixed reality and virtual reality. So you can actually produce an image of this, for example, at the factory, sitting there, and you can make this environment use the lighting environment instead of the so you can actually have this sitting kind of on a factory floor from a photo that you take, and you can actually have render this as a stereoscopic virtual reality image, which is in 3D. So you can make it feel like someone's standing next to this. And in this case, we probably want to lower the size of our environment a little bit so that the robot is a bit bigger. But it's, oops, not that small. But it's quite awesome there that you can go in and you can create an image so that you can have a trade show or any type of event like that. And you can just put a VR headset on people and they can stand next to one of your products and go, wow, like that looks really cool. And of course, it's great for using website images and that sort of stuff. So yeah, I hope that's helped. And anyone who has any questions, just let me know. Just send through any questions you have. Because I can always answer them after the webinar if you've got specific stuff relating to your models as well. Thanks for watching, guys, and we'll speak to you soon. Oh, what? Sorry, I just saw the Euroflow question. Let me just jump back into that before I click end stream. The stock sheet, really quick. That's a good question. It'll go default to the sheet metal properties dialog box. If let me just jump back into, let's bring out a sheet metal part and make one up. Oops, wrong button. I just want to bring out some stock. So when you've got your sheet metal part open, one important thing to note is that you can go in and set up your default settings in here, which I think is different to the question you're asking. But I'll go in and I'll cover that in a second. But you can change your default stock thickness by going into sheet metal and then stock in the options settings. Whichever one you leave selected here will be your default. So if I use 2 mil selected, it'll be my default. And you can edit these stock tables and things to add in all the different sizes you want to use if you want to add your own sizes in. So you can see now if I drag out a new sheet here, this one's going to be 2 mil. But yeah, the way I got into it is just right clicking go into part properties on the part. And now by default, as of I think version 2018 or somewhere around there, it'll just go straight to the sheet metal area here. And then I just click select new stock. So it may just be that I just know what buttons to press, so it seemed quick when I was doing it. But yeah, it's just part properties and then select new stock. So right click, part properties, and just select new stock. I guess if you know where your mouse is going, it can seem quicker as well, because I just know where that button is. Yeah, I hope that answers your question there. And then yeah, any other questions, let me know. Thanks for watching, guys.